Hi, today we're going to talk about compounding. So, most of the time, we are given an annual interest rate which doesn't have the effect of compounding. So, what is compounding? Compounding is a number of times that interest is calculated on a loan. So, to compute the effect of compounding, we have to first unannualize this annual interest rate to a period specific rate, then compute the effective annual rate, which is also called EAR, effective annual rate. So this is the formula, which a future value is equal to present value 1 plus R divided by N uh, to the power n multiplied by 10. So how to derive this formula? I mean, it's easier to remember this formula. You may have already done this in past, but here's a derivation which I want to emphasize on. So let's suppose we have a $1 and we invest at like 12%, right, for 1 year. So we're gonna make around 1.112 by the end of this year. Simple time value of money problem. Let's suppose if we decide to compound on semi-annually basis, so we'll be earning 6% for first 6 months. Then we again invest this entire sum, which is our principal plus the 6% which we earned in the first 6 months, again at 6% for the rest of the year. So this will come around $1.36. In case we have a quarterly compounding, so it will be like 300 for first quarter we're gonna make, then again for the next quarter, then again for the third quarter, then again we're gonna make for the last quarter, and this would come around. So as you can see, as the compounding period are increasing, like earlier we were compounding on semi-annually basis, now we are doing it quarterly basis. The effect of compounding is much more visible, and the money which we are making is bigger than if there is no effect of compounding. So what we generally given is this annual rate. We have to convert it into this periodic rate, and then compute the effect of compounding, like then compute the effective annual rate. So in this case, effective annual rate is 12.36%, and in this case effective annual rate is 12.55%. So to derive the formula, what's really happening, which we just saw, our present value, which is $1 in this case, our R is divided by N. So in case our initial R was $12, if we divide 12 by, or let's suppose in case of quarterly, we divide by 4, and what we're doing our period, which is in this case quarter, so we're gonna multiply it by 4. So that's how we are deriving this formula which we just saw here. What you see in this diagram, on x-axis you see the compounding frequency, so, and on y-axis you see the value of money, and these colors, they represent here the different interest rates. So what this figure is trying to explain here, if we invest $1 in the beginning, at blue line represent at 2% for 10 period, to in simplicity we can say for 10 years, and at 2%, so we'll make around more than $1, somewhere in between $1 and between 1 and 2. So this is somewhere around $1.21. So obviously, as we start investing at much higher rate, you can see at 12% we even make more than $3. So that's what this diagram is trying to explain. As we increasing our rate of interest, or we increasing the compounding frequency, the money which we make after a certain amount of period is much higher than if we just keep it invested on the same rate and without any compounding. Thank you.